Welcome to ICW SAUD 2020. My name is Roslan bin Talib. Together with my supervisor, Associate Professor Dr. Muhammad Zailan Suleiman from School of Housing, Building and Planning, University of Science Malaysia, Pulau Pinang, Malaysia. And this paper is regarding on this why building defects still happening in Malaysia. Okay, to start with the abstracts, this is the on the exploration of the pilot test on the building defects problem, focusing on the leakage problem, and 9 research questions been identified, and 3 of them here will be analyzed. The research somehow find out that the BLD, building leakage defects, the main problem within the construction scenario in Malaysia, and as well as part in the world, most part of the world, and construction players must actively participate to curb down this BLD to formulate a quality building type. Okay, now from the literature research, like for the information from the National Building Agency mentioned that somehow the poor design, low quality workmanship is part of the factors that allowing these defects to happen. Excluding here mentioned about the building was not constructed according to the plan, also the factor that defect will happen. So here I use this one of the local statistics experts. This is the research flowchart. I'm using this, quite simple to follow, and I think is ideal for my pilot testing. It shows that how important is the pilot testing contribute to the real survey later on. If the pilot test doesn't really works, so maybe the whole study later on, the real study maybe not getting a good result. This is the diagram that I've made on the roughly on this 3 segments that represent the construction process, potentially generating the defects in the design phase, and in terms of the product, and after the construction. You can take a look at so many variety of the building construction process that generate defect. This is the 9th questionnaire that I developed targeting to the industry players. As for example, how these defects affected the internal areas, the cost of it, estimate value is in fact impact on the money sector, economic factor, material use, for example, and so on. Okay, this is the questionnaire. The methodology used here mostly using this online questionnaire, which is a quantitative method. Okay, so this is the categories. You can have these slides. You can take a look at these slides. The Likert scale, and then I choose 3 questions. The questionnaire number 3, 4, and 5, and they have a range of the projects that they involve within a 10 years period. 5,000, 50,000, and so on, up until 1 million. Okay. Okay, we have here 21 respondents in Malaysia, most of them in Penang, 5 in Kuala Lumpur, and it's ranged from the project managers to the site engineers, site supervisors, project engineers, main contractor, including this WSC, waterproofing specialist contractor, which is the highest with 6. Now, we got table 3, 4, and 5. This is one of the 3 tables. It's first tables. Analysis on the BLD, building leakage defects. We have here the mean, the standard deviation, variance, and skewness analysis from the n equal to. So in here is described on the SD part. Yeah, you can read here that the result somehow the spaces that having roof using roofing with the tiling type roof tile is the most defect problem on the leakage issues, regardless the roof using metal roofing, clay roof tile, concrete roof tile, things like that. We give a biggest problem from this SD analysis. You can look through that. Next is on this water tank part, things like that, from these 21 participants. This mean indicate here, the mean study here, x equal 4.333, indicated the most problematic part is the metal roofing. I think this is because of it's easily rusty, not easy to maintain. Design part, not too steep, the water will it's not really running through. Number 2 on this main study of this SPSS statistics is again external roof wall. Oh, okay, external roof wall. Yeah. So the third one is the roof tile again. Yeah, with the X score with 3.7619. Okay. Seems like here the CFR, the concrete flat roof, and the aircon piping system, the water piping system also prove that is given quite a bad impact, giving more problem with the defects from the skewness statistic. The next table number 4, is the second table, is defect criteria from the BLD, building leakage defects. You can see here all the categories from the design factors, poor detailing, wrong method, wrong material, poor workmanship, and so on, including the 5 factors: lack maintenance, wrong usage of space, meaning that the designer, the architect design for something like office, it become a store, for example, like that. So heavy material being used then, and then it gives defects to the internal space. So still maintaining n equal 21, participant equal 21. And you can read here that the standard deviation, the most things is from the lacking of usage of innovative material. They don't have really a good innovative system methods to do the details and so on, lacking of maintenance, and so on. Here you can have the list there. This thing, I think this is the third one, which is the table number 5. The last one, which is on the materials to solve the leakage. When we have BLD, building leakage defects, somehow it's used material from coating layers, cementitious, liquid chemical, PU grouting, fiber, APDM, V-groove, water plug, PU, membrane, silicon sealant, and so on. You can take a look here, the same thing, the means SD and equation, and it's somehow like the most problematic for the defects is the BWM, bituminous waterproofing membrane, is typical material, covering up the CFR for the most problematic, with the SD equal 1.93218. Yeah, so seems like we have a big problem here with this membrane, as well as the next column is the cementitious liquid chemical CLC, with the SD with 1.88. So both the membrane and the liquid membrane both having problem, especially on the CFR. And so from the research, from the statistic analysis, seems like there's tremendous problems that the real research must look into from this pilot study on how the CFR been tackled, regardless the material come from France like extra or local material. So you can read here again from table 5. The mean with rating of 6.04 is the most problematic on the PU grouting. Yeah, this is to me is a temporary measure to tackle the problem. That's why it's been placed the first. I mean, like the most problematic one. And the skewness studies statistics from here indicating that there's a V-growth problem with the polymer modified mortar for the concrete, and also the usage of BWM. Okay, with all these negative 0.149, negative 0.349, and so on. And also the PU grouting system still have a problem for the defects from the skewness analysis. Well, okay, to summarize the discussions, it seems like with a total of 37 identified building defects, related components, categories, 7 to 5 range of Likert scale measurement using the 3 tables just now, that the pilot testing indicate that 80% of listed variable measured toward deep problematic range with the BLD and LDS system, the leakage defects. Uh, a total of 37 variables shows 90% of it affected a defected interior space. 90% of it. And 70% found leaking defects with all the 15 categories, sources, and 11 classes of defect criteria factors. So this is how important is the pilot studies result that can lead to the real research. Somehow is pointing out where to go of the real research from this pilot study. Thank you for listening. Thank you. Next on this conclusion part is that the leakage defects play a tricky game, as sometimes you can see the fault with naked eyes, sometimes it's not. Meaning that sometimes it's latent, sometimes it's non-latent defect games. It's just like currently this COVID-19. This is a latent defects. You cannot see it. You cannot see this COVID-19. What you call it? This virus. You cannot see it. Just effect to the people. The people died. Same thing with the defects. You cannot see it. It's a latent defects. You cannot see the naked eyes. So people think that the external labeling might look awesome. The external must look good, and but they spend more time to develop how the internal space been bombarded with all kind of defects, comments, from all angles. Eh? This require change of mindset of this industry player. Okay, you can read through that, like the wet areas in the buildings giving a lot of problems. So I think from the survey of the 21 active contributing the contribution to this sector, the Likert scale, interviews and so on, with the main SD and Questionnaire execution analysis result on about 1,000 building defects from the systematic of 15 building parts, the building components, especially on the roofing. Okay, now, okay, the last part on this conclusion is that the next phase of the study is to refine this pilot test and then refine the refinement on the further studies. We give more comprehensive structure of the survey, of the real survey, on the, either we do it in the mixed mode, the quantitative or qualitative approach of it, and fine-tuning the conceptual model, fine-tuning the RQ or RO, or even the hypothesis, as Schneider mentioned it in this book in 1994. Okay, and urge to view what is the knowledge required to all the industry players, especially like property managers, WAC, in tackling the real defects. So we hope that from that three level analysis and the selected questionnaire from that particularly 9 variables survey with the pilot test approach. I think is pilot test is very important to fine tuning and to direct which direction of the real survey, real research of this particular topic to be done later on. So with that, I thank you for your listening part in this conference. I hope this paper can contribute at least to these industries. Then I think I will convert it in YouTube. You can see it in YouTube also. And you can, if you have a question, since we have just online conference here, mail me, or I hope how my online from my village here is okay to answer your question. Thank you very much. Assalamualaikum. Thank you. Bye bye.